Here are some of the questions we want to look into in quantum numbers. Number one, find the magnetic moment of A, copper 2 ion, and B, beryllium. Okay, let's see. To get the magnetic moment of this, we said that magnetic moment is equals to square root of n bracket n plus 2, and the unit is Bohr magnitude. Yes, so when you have the electron configuration of that element, then you can now have the magnetic moment of it. Let's see what we mean. Okay, for copper 2 ion, we have it to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Yes, we stop at 3d9 because copper has 29 electron. Copper has 29 electron. So this is electron configuration of copper, so to speak. And so what do we mean by copper 2 ion? Copper 2 ion simply mean that copper as a metal is going to lose 2 electrons. From where? From the outermost shell. What is the outermost shell of copper in this electron configuration? Please, I want to ask, why we were sketching this electron configuration of elements in our first video on quantum numbers, you notice that 4s represent when n is 4, and 3d represent when the shell is the third shell. So 4s is on the fourth shell, 3d is on the third shell. Now if this is your third shell and this is your fourth shell, for instance, and this is your 4x2 and this is your 3d9, because third shell must be inside the fourth shell. Now I want to ask, should the electron leave from the innermost shell or from the outermost shell? You and I will believe or have this belief that electron always leave from the outermost shell. So what is your outermost shell? That is 4s2. So this 4s2, you are seeing these 2 electrons here will be lost. And once it is lost, what we will be having here is 4s raised to the power of 0. That means the s orbital has no electron anymore. So that means 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d9. That is for what? Copper 2 plus. So as it is like this, is unstable. It's a unstable element because this d orbital is not half filled or is not fully filled. Remember we said when d orbital is half filled or fully filled, the electron configuration is noted to be a stable electron configuration. And also if p orbitals, if they are half filled or fully filled, and if d orbitals is half filled or what? Fully filled, we said that that electron configuration is said to be a stable one. So this is not a stable one because it neither half filled or fully filled. So it is unstable copper 2 ion. Whether it's stable or not stable, it doesn't concern us as we want to talk about magnetic moment of it. Okay. Now, after noting this, you will notice that this is what? This is one orbital from the formula 2l plus 1, number of orbital. S is noted to be L equals to 0. When you are talking about s orbital, we say that L is equal to 0. So 2 times 0, 0 plus 1, 1. So 1 orbital will be for this one s. Then for this one, we say it is what? 1 orbital because it's still s. For the p, we say it is what? 3 orbitals. 3 orbitals. Then for this one, 1 orbital because it is s. For this, 3 what? Orbitals for the 3p. Then for this one, 1 orbital, which nothing is there. So there is no electron here. So there is no need of wasting our space. Then this one, d, is 5 orbitals. 1, 2, 3, 4, 5. All this will be paired because they are twos. Paired. Paired. That is what we talk about, that spin. We say upward and downward spin. Paired. Paired. Then this one paired. This one still paired. Paired. Now come to this 3D9. It will enter singly first because it is not up to 10. It will enter singly, then before what? Pairing. 2, 4, 6, 7, 8, 9. So you now see that it has only one unpaired what? Electron. Are you getting it? It has only one electron. Remember how we noted that this day we have 5 orbitals. We said D from S, P, D, F. This is 0, 1, 2, 3. So D has L to be 2. 2 times 2, 4 plus 1, 5. That is how we noted to be 5. So it has only one unpaired what? Electron. And because it has only one unpaired electron, we will now say that the formula m bracket n plus 2, magnetic moment of each, will be equals to what? Square root of n bracket n plus 2, and it will give you, where n is number of unpaired electron, that is, how many orbital has electron that is not unpaired? I mean, how many orbital has electron that is not paired? How many orbital has unpaired electron? We have only one orbital that have unpaired what? Electron. So 1 unpaired electron. So we now say square root of 1 bracket what? 1 plus what? 2 equals to 1 plus 2, 3. 3 times this, square root of 3 equals to 1.73 Bohr magnitude. The unit is Bohr magnitude. Yes. Now, because it has value for magnetic moment, because it has value of that is, the magnetic moment is not 0. Once magnetic moment is not 0, the implication is that from the electron configuration of that orbital using Hall's rule, it has both paired and unpaired electron. And in this case, the unpaired electron it has will now overshadow the paired electron, and that is where the principle of paramagnetism came in. That electron configuration of that element has both paired and unpaired electron, where the unpaired electron will overshadow the paired one, hence called paramagnetism. Okay, so because it has a value for magnetic moment, that is, the magnetic moment is not 0, we call it paramagnetic element. Paramagnetic element or paramagnetism as a phenomenon. Okay, now for the question number 2, beryllium. It has how many electrons? 4 electrons. 4 electrons. That means 1s2, 2s2. Wow, that is how it goes. So this is 1 orbital, and this will be what? Paired, because it's filled. So this is paired, this is paired. How many unpaired? orbital does it have? How many unpaired orbital does it have? No. Everything is paired. Each of the orbital, the elements there are what? The spin there are paired. So no orbital is unpaired. And because there is no orbital that is unpaired, we say that n will be equal to 0. Number of what? Unpaired orbital is what? 0. Therefore, magnetic moment will be like 0 plus 2. 0 plus 2 is 2. 2 times 0 is 0. Square root of 0 will be what? 0 Bohr magnetic. That is where the name diamagnetism comes in. That is, beryllium is a diamagnetic element. Why? It only have paired electron. It only have paired electron and no unpaired electron. And because it has no unpaired electron, it means that unpaired electron of it is 0. And so it will be called a diamagnetic element, or principle of diamagnetism will come in there. That is about question number 1. I believe you understand it very well. And so if you do not understand any point of it, aspect of it, please make use of the comment box below and ask your question. Thank you. We go to question number 2. We say, what is the maximum number of electron orbital? What is the maximum number of electronic orbital with the following set of quantum number? Watch. For A, we say the formula is what? 2 bracket 2L plus 1. Where L is 1, 2 times 1. 2 bracket 2 times 1, because L is 1 plus 1. Okay? And so what it will be giving you, 2 plus this, 3 times this, 6 electron. Yes, that means that this is talking about what? P orbital. P orbital. That means it's talking about 2p what? 6. This short shell 2p6. That is why we have 6 electron. 2p6. Where n is 2, p is L equal to 1 and 6 electron. Then for B, wow, n is equal to 3, L is equal to 3. Please don't just say 2 times 3, 6 plus 1, 7, 14. Please don't try that, because you see value of L. We said that when n is equal to L, when the value of n is equal to L, the implication is that the orbital is mechanically what? Forbidden. It's mechanically forbidden, so we don't have such. This is mechanically forbidden. We go to question number C. We say that this is less than this. Yes, L must be less than n for you to have for the orbital to exist there. So for it not to be mechanically forbidden, L must be less than n. Okay, we now say that the formula is 2 bracket 2 times our L is 2 plus what? 1 equals to 2 times 2, 4 plus 1, 5, 5 times 2, 10. That means this is talking about 3. L is 2 and it's talking about d orbital. Okay, 3d what? 10. 3d10. That is the subshell that is talking about. We go to the next one. Write the stable electronic configuration of copper plus 1 and what? Zinc 2 plus. Electron configuration. For you to be able to write it well, please and please do not forget what I've been saying. That for electron configuration of an element to be stable, the P should be what? Half filled or what? Fully filled. That is P3 or P6. Or D is half filled or what? Fully filled. This is the cases that are involved. Okay? Okay, so what we will do here is we now say for copper. Look at for copper. We have drawn it before now. Now for us to say that copper is a stable electron configuration, one element from 4s2 will jump and enter this d orbital to make it 10. And so we'll be having it to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s1, 3d10. That is electron configuration of copper. That is for copper. Yes, remember we said it must obey the rule that either it is half-filled or fully filled for p and d orbital part of it. So because the d ends at 9, this will move from 1 electron will move from this 4s2 and enter here to become 3d10. This is the electron configuration of copper in a stable state, or the stable electron configuration of copper. Now for copper 1 electron, copper 1, for copper 1, it means that 1 electron will move from here. It will give out 1 electron to a non-metal. It has to give out 1 electron to a non-metal. And so copper 1, in copper 1 here, there will be only what? 1 electron. Then you call it copper what? 1. Why are we removing 1 from the 2 we have here? Please, why are we removing 1 from that 2 you have there? It is because for a metal to give out its electron, it will give it out from the outermost shell. And so the outermost shell of this electron configuration is 4s1. That is the last shell, the fourth shell. The third shell is inside the fourth shell, as we discussed before now. So the outermost shell is 4s shell, 4s subshell is inside the outermost shell, which is the fourth shell. And so electron will leave from this. And when the electron leaves there, it is 1 electron, because here I said 1 electron. It will leave from there. That is about copper 1. But the question is this electron configuration stable? The answer is no. It has to obey the rule of P3, P6, D5, D10. And how can it obey it? This 1 electron will jump and enter here, making it 10. And so we'll be having it 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d10. This is for what? Copper what? 1 ion. This is the stable electron configuration of copper 1 ion, whereas this is the unstable aspect of it. Okay? Then we go for this zinc 2 ion. That means the zinc will be losing what? 2 electrons. Now, how do we do that? We go to this. Zinc has 30 electrons. It has a total of 30 electrons, whereas copper has 29. Okay, we go back to here so that we will not waste our time resketching. We now say this is 4s2 and 3d10. This is about 30 electrons. 4, 10, 20, 30. So 30 electrons. That is for what? Zinc. Now for zinc 2 plus. Zinc 2 plus means it will lose 2 electrons for the outermost shell. And the outermost shell we have is the fourth shell. And this 4s2 is a subshell in the fourth shell. And so 2 electrons will leave from this electron to be given to a non-metal. And so we now have it to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s0, 3d10. That is for zinc 2 plus. It means that it lost the 2 electrons at its s orbital. It means that it lost 2 electrons that is meant to be at the 4s orbital. Do you notice now that a question can be asked from here? Which of these ions or elements have same stable electron configuration? Copper 1 plus and copper 2 plus have same stable electron configuration. So they obey this rule we just mentioned. Have it in your mind. Okay? So if you have a question in any of these questions we just solved, please feel free to use the comment box below. All this square root and all have you. Check it and confirm it. Okay? Then, which of these orbitals is the most stable? That is question number 4. Which of these orbitals is the most stable? For you to know if this is stable or most stable, and if this is not, you have to get their energy. How you will get it from the energy of it is that you now say the one with lowest energy is said to be the most stable one. Okay. How do we calculate the stability? We say N plus L. Calculate their N plus L. N of this is 3. L of this is 2. Look at it. L of this is 2. This is their L. L of this is 2. You now say 2 plus 3, 5. 4 plus 1, P is 1. 4 plus 1, 5. 5 plus 1, 6. 5 plus, what is your D? D is 2. 5 plus D, 7. And so, we will say that these have the highest energy. These have the highest energy. And since it have the highest energy, this is least stable. Least stable. Highest energy. Highest N plus L, that is highest energy. Now between this and the which one should be taken to be the lowest energy? The one with lower value of N is said to be the lowest. So N of this is 3, while N of this is 4. This is lowest energy. Lowest energy. Hence most stable. Hence most stable. So this is most stable because it has the least energy. The energy value is 5. This one energy is 5. But because the N value, this 3 is lower than 4, we take it to be the lowest energy. So the lowest energy is 3D. And so, because it's lowest energy, we say it is the most stable. This one, the highest energy, and so we call it the what? The least stable. So have them in mind as you watch it. Okay, we go to the last question. The last question says, calculate the element. If N is 3, L is 2, M is 0, S is half. Wow. Now see what you do. Check the number of orbitals when L is 2. 2 times 2, 4 plus 1, 5. I will write what? I will draw 5 orbitals. Okay? Now, what this means is that elements, this is 0. The middle one is labeled 0, minus 1, minus 2, plus 1, plus 2. Yeah, that is about the magnetic what? Quantum number of it. When L is 2, the M will be minus 2, minus 1, 0, 1, and 2. Now, electron will be entering singly first before what? Pairing. Okay? And it has to stop at M equal to 0. These are values of M. It has to stop at M equals to 0 in clockwise direction. Watch it. singly, singly, singly. This is m equals to 0, and this is clockwise direction. If here is minus half, if here is minus half, it means that it will get filled and start going for downward, and stop at m equals to 0. That is, if it is minus half, it will stop at downward spin at m equal to 0. Here will be filled. So it will enter singly, get filled, and start pairing, so that the downward spin, which is half, will be at m equal to what? 0. But they said it is plus half. And so what we do is that we maintain the question they ask us. We just stop at the question they ask us. Plus half means it stop at what? M equal to 0 via upward spin. Then that means the total electron we have is 3. Now L is talking about 2, that is d orbital. D. Then how many elements do we see here? 3. Then what is your n? N is what? 3. N is 3. And so what you will do is that you say the elements will be gotten this way. You will be writing 1s2 and stop at 3d, 2s2, 2p6, 3s2, 3p6. Then you now also have 4s2 and 3d3. Okay? How many electrons? 1, 2, 10, 20, 23 electrons. Which element has maximum of 22 electrons? 23 electrons. Which element has 23 electrons? 20 is scandium, 21 is scandium, titanium. Okay, so this is what? Vanadium. Vanadium. So the element we are looking for here is called vanadium. That is the one with 23 electrons. That is the one with what? 23 electrons. Okay? So that is how to solve these questions we have for today on quantum numbers. Thanks for watching the video. Please don't forget to click like button, comment, click share to your friends. Yeah, I appreciate. For the one you have done for me, share it to a friend watching my videos. I appreciate. Thanks very much.
Chasing waterfall.